So in this section, we're going to look at infinite geometric series. Let's consider these two different geometric series, okay? Example A, notice that the value of R, the common ratio in here, is a half. And if as you go through the series and you add the next term and the next term in the series, you notice that it gets smaller and smaller and smaller. And if you take out your calculators and add all of these up, there is a value that you're going to come very close to, and this value will end up being 10. Okay, it's very simple. You just have to add those. Okay, but remember that you keep dividing every term by 2, that's the common ratio, and then you write the succeeding term. But here, look at example B. The common ratio here is 2. Now, is there any actual sum? Can we come up with the sum? In here, the first example, the sum of this term, the sum of the series, we don't know how many terms that would be in there. We're going to talk about that. That's 10. But can we come up with the sum in here? Well, not really, because you keep doubling it, and these numbers, the series is going to continue going forever because the number is getting bigger and bigger and bigger. And mostly it's because of the common ratios. Look at the R equal to 2 and reference it to R equals to half. You see, R equal to half gets smaller and smaller, and approaches, basically makes each succeeding term of a geometric series is smaller than the term before. That means that it's come closer and closer and closer to 0 at the end of the series. But when R, the common ratio, is bigger, you will always get a larger succeeding term than the term before. So this is why we need to talk about the infinite geometric series and look at these two concepts and realize that one will have a sum, the other one will not have a sum, depending on the common ratio. So here is the guideline for it, and I would like to show it to you using the formula for the sum of the geometric series. Now we have this formula, we already know that. Let's expand that formula. So that would be AR to the n minus A divided by R minus 1, and then let's break it up. So we're going to break up this this fraction right here. We're going to break it up as AR to the n divided by R minus 1 minus A divided by R minus 1. So we can do that, right? That's the fraction. We can break it up like that. But here's the thing. When you're looking at the value of R in the terms, knowing that R cannot be 1, obviously, because if it is, this denominator, this rational expression, will have a denominator 0 that will be undefined. That is not allowed. But what you can do is this, that as n gets bigger and bigger and bigger, so look at the value of R, and we are using the absolute value. That means that we just want the positive value of R. If that value is less than 1, okay, if it's less than 1 in terms of the value, that means that it has to be between 0 and 1. That's what the absolute value is covering, that, okay? Then R to the n, then this term right here, R to the n, will become very, very, very small value. And when you have so small that it's going to be like close to 0. And what do you have when you have 0 divided by R minus 1? Well, that will be 0. So this first term will go away. So what you will end up getting, the sum infinite series, and that little infinite sign, that's for the notation for the sum of the infinite geometric series, will end up being minus A over R minus 1, or more compact form without the negative will be A divided by 1 minus R. This is the formula for the sum of the infinite geometric series, and the only way that you will have a sum, remember, R, so only way you will have a sum if absolute value of R is less than 1. If it is bigger than 1, no sum, because you can't add if absolute value of R is greater than 1. Simple as that. Okay? So let's look at this example. Find the sum of each infinite geometric series. We're going to go through a couple of examples. The first one is 8 plus 2 plus half plus 1/8. We want to find if there's a sum, and if there is, what it is. Okay. Let's look at A. A is 8. But the part that you have to really pay attention to is the common ratio R. And then in this case, you want to double check. So R, absolute value of R, is quarter. That means it is less than 1. That means you will have a sum. The infinite geometric series will have a sum. So now we're going to go through and plug it in. So what do we have? We have the infinite geometric series equals to, and then we're going to use the formula that we have. A on top, which is your first term, 8, divided by 1 minus a quarter. So 8 divided by 3/4. And in this case, you just go through, that would be 32 divided by 3. That is it. Okay, let's look at this example. Infinite geometric series. So let's write up the information that we have. Your first term is 4. Very good. What is your second term? Well, the second term is minus 6. So what is the common ratio? The common ratio R is, if you want to know exactly, so remember, you just divide. Minus 6 divided by 4, that will give you the common ratio. So in this case will be negative 1.5. So now you have to check, is negative, absolute value of negative 1.5, is that less than 1 to get the sum? Well, it's not. 1.5, it is not. It is not less than 1. So what you can say, therefore, this geometric series has no sum. And you're done. You don't have to use that formula because that formula doesn't apply. Okay? That's simple as that. So it is important that you notice that this infinite geometric series has no sum. Now, if n was given to you, that means, let's suppose that you want to find the S 50. That means the sum of the first 50 terms of this geometric series. Sure, this will have a sum because you already have 50 terms that you're adding, so that would be finite. But if it's infinite, that means you got dot, 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 that means going forever, you will not have a sum. So let's look at this question. It's a little bit of an intense question, but I like to bring it up. So in this case, we want to find all values of x so that this series will have a sum. So what does that mean? When he says it has to have a sum, that means that you must have your R, the common ratio of this series, must be less than 1, the absolute value of that. Okay, what is the common ratio? For this one, remember, you just divide the x by the term before that, you will get the common ratio. So in this case, the common ratio is x. So now we have to say absolute value of x must be less than 1. Okay, so that means we need to solve this absolute value inequality. Okay, so we need to solve this absolute value inequality. And if you remember this from previous grade, so absolute value of x that is less than 1, you take two cases. Case 1 is that you take the positive value x less than 1, and then that would be your first answer. Okay, and then we'll double check, of course, and then we go from there. We take the positive value right there. Case number 2, we're going to take negative x less than 1 and solve for x, so x has to be greater than negative 1. And then basically between the two we need to make sure we put them together. So on a number line we put them together. This is negative 1, that is 1, that is 0. So what we are looking at all the values in between negative 1 and 1, not inclusive. So that means that's the answer. Then the way you write it is like that. And these are the only values of x that makes that geometric series, this infinite geometric series, having a sum.